In my last video, we talked about machine learning, how computers learn from data to make predictions. But you've probably heard another term thrown around, deep learning. What's the difference? Are they the same thing? Or is deep learning something completely different? Here's the thing. Deep learning is actually a type of machine learning, but it's a really powerful, really specific type. And understanding the difference will help you understand how modern AI actually works. By the end of this video, you'll know exactly what separates deep learning from regular machine learning and why it matters. Let's dive in. First, let's quickly recap what machine learning is. Remember, machine learning is when computers learn patterns from data without being explicitly programmed. You show it examples, it finds patterns, it makes predictions. That's the core concept. Now here's where deep learning comes in. Deep learning is a subset of machine learning. Think of it like this. All deep learning is machine learning, but not all machine learning is deep learning. Deep learning uses something called neural networks, and I'll explain what those are in a moment. But the key difference is in how complex the patterns it can learn are. Regular machine learning is great at finding patterns in structured data, like people who buy X also buy Y, or emails with these characteristics are spam. It's looking at specific features you've identified. But deep learning can find patterns in unstructured data, images, audio, text, video, things where the patterns aren't obvious. It can learn incredibly complex, layered patterns that regular machine learning would struggle with. So let's break down the actual differences, because this is where it gets really interesting. Difference 1. Complexity of patterns. Regular machine learning is like having a really good detective who can solve straightforward cases. They look at the clues you point out, they find the pattern, they solve the case. Deep learning is like having a detective who can solve cases you didn't even know were cases. They look at everything, all the details, all the connections, all the subtle relationships, and they find patterns that are incredibly complex and layered. For example, if you want to recognize handwritten digits, like reading zip codes on envelopes, regular machine learning might look at specific features. Does it have a loop? Is there a straight line? It's looking at features you've defined. Deep learning, on the other hand, looks at the entire image. It learns what makes a 3 look like a 3 by seeing thousands of examples. It doesn't need you to tell it what features to look for. It discovers those features itself, and it can discover really complex ones. Here's a big practical difference. Regular machine learning can work with smaller data sets. You might need hundreds or thousands of examples, and it can do pretty well. Deep learning is hungry. It needs massive amounts of data. We're talking millions, sometimes billions of examples. But here's the trade-off. With that much data, it can learn incredibly sophisticated patterns. Think about image recognition. To train a deep learning system to recognize cats, you might need millions of cat photos. But once it's trained, it can recognize cats in situations it's never seen before. Different angles, different lighting, different breeds. Regular machine learning would struggle with that level of complexity. This is a really important difference. With regular machine learning, you often need to do something called feature engineering. That means you need to identify what aspects of the data are important. You're telling the system, look at these specific things. With deep learning, the system does feature engineering for itself. It learns what features are important through the training process. You just feed it raw data, images, text, audio, and it figures out what matters. This is huge because it means deep learning can work with data that's really hard for humans to describe. How would you describe what makes a face look like a face? It's really hard to put into words, but deep learning can learn that pattern from examples. Let me give you some concrete examples so this really clicks. Think about email spam filters. The system looks at specific features. Does it have certain words? Is it from a suspicious sender? Does it have lots of links? These are features that humans can identify and describe. Regular machine learning works great here. Or recommendation systems. People who liked this movie also liked that movie. The system is looking at clear, structured data, user ratings, movie genres, viewing history. Regular machine learning handles this really well. Or predicting house prices. You give it features, size, location, number of bedrooms, age. The system learns the patterns. This is classic machine learning territory. Now, image recognition. Your phone recognizing faces in photos, that's deep learning. The system has learned to recognize faces by seeing millions of examples. It's learned incredibly complex patterns about what makes a face, the relationships between features, the way light affects appearance, different angles and expressions. This level of complexity requires deep learning. Or speech recognition. Siri, Alexa, Google Assistant, they use deep learning. They've learned to understand human speech by processing massive amounts of audio data. They've learned patterns in how humans speak that are way too complex for regular machine learning. Or language translation. Google Translate uses deep learning. It's learned the patterns of language, grammar, context, meaning, by processing enormous amounts of text in multiple languages. The patterns it's learned are incredibly sophisticated. Or self-driving cars recognizing objects on the road. They need to identify cars, pedestrians, traffic signs, lane markings, all in real time, in different lighting conditions, from different angles. This complexity requires deep learning. So when would you use regular machine learning versus deep learning? Use regular machine learning when you have structured data with clear features. You have a smaller data set. The problem is relatively straightforward. You need results quickly and don't have massive computing power. You can identify the important features yourself. Examples: spam detection, recommendation systems, predicting sales, fraud detection. Use deep learning when you're working with unstructured data, images, audio, video, text. You have massive amounts of data. The patterns are too complex for humans to describe. You need to recognize things that are hard to define. You have the computing power to train complex models. Examples: image recognition, speech recognition, language translation, autonomous vehicles, medical image analysis. The key is, if you can describe what features matter, regular machine learning might be enough. If the patterns are too complex to describe, you probably need deep learning. Now, here's something important to understand. Deep learning isn't replacing machine learning. They work together. Many real-world AI systems use both. For example, a self-driving car might use deep learning to recognize objects in images, but use regular machine learning to predict traffic patterns based on historical data. They're tools in the same toolbox, each suited for different tasks. And here's why understanding this difference matters. It helps you understand what's actually possible with AI. When you see an AI system doing something really impressive, like generating images or understanding natural language, you'll know it's likely using deep learning because of the complexity involved. It also helps you have realistic expectations. Deep learning requires massive data and computing power. Not every problem needs that level of sophistication. Sometimes regular machine learning is the right tool for the job, so there you have it. Machine learning is the broad category. Computers learning from data. Deep learning is a powerful subset that uses neural networks to learn incredibly complex patterns, especially in unstructured data like images, audio, and text. The key difference is, deep learning handles more complex patterns, needs more data, and does its own feature engineering. Regular machine learning is great for structured data and simpler patterns. They're not competitors, they're different tools for different jobs. And understanding when to use each helps you understand how modern AI actually works. Now, we've mentioned neural networks a few times. Those are the structures that make deep learning possible. In my next video, I'm going to dive deep into neural networks, how they actually work, how they learn, and why they're so powerful. If that sounds interesting, subscribe and hit the notification bell so you don't miss it. If this video helped you understand the difference, give it a thumbs up. It really helps the channel grow. And as always, drop your questions in the comments below. What confused you? What do you want me to explain next? I read every comment and I'd love to hear from you. Alright, that's it for today. I'm Sam, and I'll see you in the next video. Thanks for watching, and keep learning.